Hello, and this is another video for AQA GCSE Physics higher and foundation students on specific heat capacity and specific latent heat. Specific heat capacity is the energy required to raise the temperature of 1 kilogram of a substance by 1 degree, and this is displayed by the equation Q equals mc delta theta, where E is the energy, m is the mass, c is the specific heat capacity, and delta theta is the change in temperature. Now this needs to be known by both higher and foundation students. However, it is unlikely if you're doing foundation you'll be asked to do many calculations based on this formula, but if you're at higher, do be expected to be asked about this. Now you may also see this written as, instead of E, it might be Q, but for this I'm just going to use E. You might also see the delta theta written as delta T for temperature, but they're both the same thing. So if you do see, for example, delta theta, just know that means change in temperature, but if you see delta T, then that just means change in temperature as well. Now the triangle here, that just means delta, that is just changing, and then this symbol here is for the temperature. The specific latent heat of a substance is the energy required to change the state of 1 kilogram of a substance without a change in temperature, and this is shown by the formula E equals ml, where E is the energy, m is mass again, and L is latent heat. Again, this needs to be known by foundation and higher students. However, foundation won't be asked too many questions using this formula. Just drawn a small graph here just to show what specific latent heat is. On the y-axis here I've got degrees C, that's for temperature, and on the x-axis here I've got time, which is in seconds. Now let's say this is a material or a substance. Here it will be at a solid, whereas here it is at a liquid. At this point here, this will be the specific latent heat of fusion. Now you don't really need to know that, but you need to point out that this is the specific latent heat because there is no change in temperature. However, there is a change in state, and that's because all the energy is used to break the bonds in the atom to change the state instead of increasing the temperature. Okay, so I'm just going to touch on pressure really quickly as well. Now, for triple students, I'll go more in depth into pressure, but this is for higher and foundation students. For doing combined, this is all you really need to know. So the molecules in the gas are in random motion. They're moving around randomly. You can't predict where they're going to go. And the temperature relates to the average kinetic energy. So if you increase the temperature or you increase the kinetic energy, that will increase either the kinetic energy or the temperature of that substance, because they will move around quicker, and they will collide with the walls. They will collide with each other. So when the molecules collide with the wall of the container, they exert a force onto that wall of the container. Now this force per unit area is the pressure. So the pressure is just going to be the force per unit area exerted by the molecules. So if you have a stronger force, then the pressure will be larger, which is why gases exert a larger pressure than other states of matter, because they exert more force, because they're moving more quickly, because they have a higher average kinetic energy. For example, if you have ice at 0 degrees, the average kinetic energy of the molecules in that substance is going to be very low, so it's going to exert less force, it's going to have a lower pressure. Whereas if you have a gas, the molecules are going to be moving around very quickly, so their kinetic energy is quicker, so they collide with the walls more frequently, so they exert more force, and so they have a higher pressure. And that's the end of the video, so thank you.